whiskey distillation, a seminar on whiskey distillation. So distillation is just one piece of whiskey making though, so we're going to kind of take you guys through from grain all the way to bottle. And there's a lot of science behind the barrel maturation thing, so we might sort of scoot through that quickly unless you guys have questions on that. But feel free to ask as we go, and we can expand on certain aspects of the production process and maybe cut through some of the others, just depending on what your interest is. Just to get an idea of your general knowledge, any people who have been to a distillery before? All right, good. Okay. People who understand the malting process? Okay, good. People who have tasted whiskey before? Yeah, okay, good. All right, good. So this is kind of a 201 class. This is not just the basic, all right, well, you boil off the alcohol and collect it. I'll get a little bit deeper into it. But we're going to start just sort of going through what whiskey is, kind of definition of whiskey, and the different types of whiskey, and then we'll get into everything from grain selections to barrel maturation and filtering. So definition of whiskey. Can anybody? So I got a couple of prizes in case anybody can answer some questions for me. There's only a couple. So and this one is not a prize question. I'm just telling you there are prizes. All right. Can anybody tell me what the definition of whiskey is? Yeah.
It's a grain-based spirit. The root word is "viskeva" from the Gaelic, which means water of life, the same as vodka or the alcohol.
Good, right, and then depending on the different places where whiskey is made, depending on the grains that they're made from, and depending on the way that you treat it afterwards, either maturation, barrel maturation, or resting, or no maturation, will distinguish the different types of whiskey. So yes, thank you, Bob. That is correct. I feel that almost exactly Bob's point. There you go. And then when the top one is the American whiskey definition. And then the bottom one is just a little bit more broad because whiskey is a very generic umbrella term, whereas you got very unique different types of whiskeys made around the world. Let's start with a quick history of distillation. Go back, I guess, 2,000 years, and we have early evidence of distillation in Egypt, and the alchemists of Egypt and the Arab alchemists were using distillation mostly as they were trying to turn things into gold. I mean, it really was alchemy back then, and also for purification. When we start talking about grain distillation, though, we're getting up to the 1400s. So it wasn't until the 1400s that we just start to see evidence of grain distillation. And the fractional distillation was created in the 1200s. A fractional distillation is what sort of paved the way for potable spirits, because that's where you can actually separate out the good stuff that we want, the ethanol and the good flavors, and take out the dangerous, toxic components of fermentation process. Single malt scotches, you started to see scotches in the 1600s. That's when it really became prevalent in the 1600s. There were obviously people were fermenting before that, but it really started to start to see some evidence of Scotch distillation, malted barley distillation, rye, and you don't actually see corn distillation until we get over to the Americas. And in fact, the earliest evidence in the United States of corn fermentation and possible distillation was Thorpe, Captain James Thorpe, who was a missionary, and he was in Virginia, and he talks about using the indigenous corn or maize that the native people were using for all different aspects of life, and turning that into what could be maybe construed as a spirit, or maybe it was a corn beer, but this is the real first written evidence that we have of corn being used as a fermentable and then potable product. And then he got the natives drunk and they scalped them. So. But you don't really see a lot of grain distillation until the 1700s in the United States and late 1700s. But you saw a lot of early distillation in the United States was brandies, fruit brandies, rum, and we were not only importing rum from the islands, we were also importing molasses, and you were seeing a lot of rum distillation in New England. And New England was one of the points on the triangle trade. So you were getting molasses or rum up from the islands, and we were also exporting rum out of New England and then around the colonies at that point. You start to see a lot of, so it became sort of patriotic to drink grain-based spirits as we get towards the sugar tax in the 1700s, and also when we get to the Revolution, because they were actually taxing sugar that was coming from anywhere outside of the empire. And that meant that if you weren't buying molasses or rum from colonies of the crown, you were getting super high taxes, and that was also, that means you were taxing farmers here, and they were taxing spirits that were being made here. So we're going to get through this really quick. In the 1700s, you also start to see the Scotch-Irish coming over in mass, and a lot of distillation knowledge came over, grain distillation and fermentation knowledge came over with the Scotch-Irish, and they became really the backbone of the distillation, of distilling in the United States, particularly for grains. One really interesting thing about Kentucky, everybody thinks, well, I think in this room people understand that bourbon doesn't necessarily have to be made in Kentucky, but it's obviously where most of it is made, and really the birthplace of American bourbon. And one of the reasons why is because a lot of the farmers, when Kentucky was created, it was sort of carved out of other states, and partially a lot of the farmers went down to Kentucky when the Corn Patch and Cabin Rights Act was created. And what that did is it said that if you go down to Kentucky in the late 1700s, you can claim up to 400 acres of land if you build a cabin and you plant some corn. And it was free. You didn't have to pay for that land. You just go down there, you can claim up to 400 acres as long as you planted corn, you build yourself a house. And you see a lot of people, farmers and distillers moving down into Kentucky, planting corn, and of course we're really going to use that corn for a number of things, including fermented and then distilled spirits. Any questions on history? I want to move on into the fermentation and distillation processes. But just a couple other things. We've got the Volstead Act in 1920. That was when, it was obviously the beginning of Prohibition, and that was when all the distilleries were shut down with the exception of, I think, 6 distilleries, and some names that you still know. Actually, that's a question that I wanted to give a prize out for. Does anybody know, at the end, we'll get to it, you know, all 6? Does anybody know all 6? The 6 distilleries that survived through Prohibition. There was actually given permits to produce medicinal spirits through Prohibition, and some of them are still around today. You have Brown-Forman was one of them. Anybody know some of the others?
Heaven Hill.
Heaven Hill.
Buffalo Trace, even though it wasn't called that then.
Was that what
Buffalo Trace, even though it wasn't called that.
It wasn't Buffalo Trace. There was, I think.
I can't remember.
All right, we'll get to. I actually have the answers at the end, so we'll get to that. And then, on this day in 1933, Prohibition was repealed. And that's important for us in New York, for us at Hudson Whiskey, because there were actually no distilleries in New York State from the time when Prohibition was repealed up until the early 2000s, when we got our license. And that was because of really prohibitive licensing fees. You could produce as much as you wanted, but you had to pay $60,000 a year for the license. That licensing fee went down significantly in the early 2000s, and that's why we were able to pop up and start making spirits in New York again. And now the laws are quite friendly in New York State, and it makes it feasible to have a small operation. And then from 1933 to 1982, lots of things happened. Whiskey was drank, whiskey was produced. Plenty of other non-whiskey related things happened, I think, from 33 to 82. And then in 1982, you actually start to see some of the early craft distillers in the country. And some of those craft distillers, most of them were in California. You had guys like Marco up at Mature Bay. You had St. George, your group at St. George, and Germain Robin. These guys were in the early 80s. And then you didn't really see a propagation of craft distilleries again until the late 90s and early 2000s. And now you're starting to see that sort of second wave of craft distilleries. But a lot of the early distillers, and craft distillers at least, were making fruit brandies, and those were in California. All right, now on to the process. So grain, I just made that quote up earlier today. Find some sugar and make it high. Because when you're using fruit such as apples, which we use at our distillery, or pears, molasses, if you're making rum, you already have accessible sugar. When you're using grain, you've got starches. These are complex carbohydrates. You need to be broken down into simple carbohydrates or sugars so that they can be consumed by the yeast, and the yeast can poop out alcohol and CO2. So, how do you find those sugars? How do you get to those sugars? There are a variety of different grains that you can use. Just some pictures of the grains, the typical grains that are used for whiskey. I threw in some heirloom varietals of corn there, because we actually use some heirloom varietals. Most whiskey is made with field corn. We do use field corn, but we also use the heirloom varietals for the oils that we're getting out of there, the flavor congeners, and the mouthfeel on the final product. So a small amount of these heirloom grains, even though they're very low yield, can really make a flavor profile difference on the final product. You can see some malted barley and different types of malts up top, different types of roasts, different types of malts. Malted barley in the middle, there's some rye down on the left there. We've even got distillers now making whiskey out of quinoa and millet. Some oats, we've got some oat whiskey in barrels at Tuttletown or at Hudson. So these are the main grains that we're using. I didn't put in wheat because there's wheat berries back there. Those are wheat berries. All right, so when we talk about the different types of whiskey, bourbon, right? Primarily corn, at least 51%, no less than 51%. Anybody know any of the other regulations on bourbon? Besides Bob?
First,
yeah.
It's gotta be aged for at least 3 years, right?
No, so there is only an age requirement on bourbon if you call it straight.
Oh,
So, and that's 2 years. Unless you lived in Europe. If you lived in Europe, then yes, at 3 years. And that's something we've been working on actually, is changing that law so that it's reciprocal. They can call whiskey over here whiskey, but we can't call a whiskey over there unless it's at least 3 years. So you got bourbon.
distilled no higher than 180.
160. 160, yeah. Good. Anybody else? Yeah. Another one?
Has to be aged in first fill American oak barrels.
Right.
And it can't go in above 140.
Into the barrel above 125.
125.
That's right. Now, interestingly, you will find bourbons that are higher than 125. How does that happen? Yeah.
Well, depending on the weather, sometimes the water evaporates out more than the alcohol.
Yeah, it's cool because in Kentucky, you're actually the water is evaporating out of the barrels faster than the alcohol is. However, in Scotland, it's actually the opposite. You're actually losing alcohol, and the proof is going down. Is that right, Tim?
Yeah.
That's right. Good. But in New York, we lose them about at the same rate. So we're actually just losing volume. The proof stays about the same. But that's true. It depends on the environmental factors, and water or alcohol will evaporate out through the wood.
No added flavors.
No added flavors. Yes, then you can actually add up to 0.25, I think 0.25% or 1.25%.
I know you can't mellow it.
Yeah. Well, this
That's
is
the argument.
What's
Jack
that?
Daniels is the argument. You can't mellow the charcoal mellow. Jack Daniels makes it.
you can charcoal filter bourbon. So there are 6 main points to bourbon. You got to be at least 51% corn. I think we got most of them. It's got to be aged in new charred white American oak barrels. It can't come off distilling higher than 160 proof, or 80% alcohol content. Can't go in the barrel any higher than 125 proof. Can't go in the bottle any less than 80 proof. It has to be made where? I'll give you a hint. It's not Kentucky. United States, that's right. Any of the United States you can make bourbon in. And if we age it for at least 2 years, we can call it straight bourbon. And that goes for all whiskeys. But that's bourbon. The rules of bourbon are true across all American whiskeys, except for the one factor that changes, which is the grain. So if you followed all these rules of bourbon, but changed at least 51% corn or at least 51% rye, then you've got an American rye whiskey. Now, if that barrel was used, right? If we made some Hudson 4-grain bourbon, we dumped out that barrel and refilled it. Do we call it bourbon? What could we call it? We could call it whiskey. We could call it whiskey, yes. Or you could call it whiskey made from a bourbon mash, and you're just going to get lighter flavor profiles on that for the wood. Irish whiskey, so I might lean on you for this, Tim. But mostly made from malted barley and corn, is that right?
Yeah, we can use wheat. Nobody is. I've seen oats, but you're exactly right. Barley and corn,
Cool. And triple distilled. Irish whiskey is typically triple distilled, right?
but not a lot.
Not a lot.
Anything from the Cooley distillery is double distilled. Anything from the Cooley distillery is double distilled.
Double distilled, yeah, okay. Single malt scotch. Single malt scotch is going to be made from malted barley. Where it's going to be made? It's going to be made in Scotland. Scotch tend to come off the still at a lower proof than American whiskeys do. We can't go off distilling higher than 80% alcohol content. And typically for us, we'll come off somewhere between 75 and 80%. Whereas in Scotland, you're seeing it coming off quite a bit lower. And often they will not cut it with water before it goes into the barrel. So, it'll come off the still somewhere in the 60s, and then it'll go straight into the barrel. Rye whiskey, we already talked about. Rye whiskey, American rye whiskey, and Canadian rye whiskey are two separate things. So there is no grain requirement on Canadian rye, other than that it's got to have some rye in it, and it's got to have, I think, have flavor profile of a rye whiskey. I don't know so much about Canadian whiskey. So now we've got the grain. We've got to figure out how to access those sugars. We want to get to the sugars so we can get high, right? We're going to mill the grain so that we can access the starches. We're going to cook it into water, and we don't want to go into a flour at this stage. We want to go more like a meal-like consistency, so we can get at those starch molecules. So what we do is we use a hammer mill. We grind the grain down into hot water. We cook it. We're looking for a certain sugar content or a certain Brix level. In order to do that, we're looking for the right blend of water and grain. And for us, each batch we have a 900 gallon cook tank, and that takes about 1,600 to 1,800 pounds of grain and about 750 gallons of water, and we end up with about 900 gallons of mash. There's two ways that we're going to convert that starch into sugar, through heat and through an enzymatic process. Now we talked about, asked you guys quickly who understood the malting process. So there were a number of people who didn't raise their hands. So really quickly, but basically you're starting the germination of a seed, and then you're stopping that germination. And what happens when the seed cracks open, so first you put grain into water, and typically this is done with malted barley, but it can be done with almost any grain. You can malt, I think, any grain. You soak it in water until the seed starts to germinate, and it'll crack open. As soon as it cracks open, you drain out the water, and spread it out onto a floor. They'll rake it, and now it's done mechanically in a lot of the big malting houses, but they would rake it to make sure that the roots don't tie it up and get all clogged together. And then they would put it into a kiln where you're going to dry the grain. Now in Scotland, when we get peaty scotches, peat used to be the heat source, not just for malting, but for your homes, for everything. So they used peat as the way to dry the grain in the kiln. So put the grain out onto a perforated floor, you hit it from below with heat, stops the germination, dries out the grain, and what's accessed there is an amylase enzyme, which in that individual seed would convert its own starch into sugar and then spark the life of the plant. So what we're trying to do is capture that amylase enzyme so that when we add it to our mash or to our whiskey mash or beer, it's going to convert not only its own starches into sugars, but also the starch from the mash and the other grains that you're adding it to. And you can do just a small amount of malted grain. You can do 5% to 10% of malted barley to 90%, 95% of corn or rye or wheat, whatever. And that small amount is going to kickstart the starch conversion and convert the starch in that mash into sugar. You can also use enzyme, which is derived from malted grain, and it comes in a liquid form. And you can add that, and that would help to also break down starch into sugar. We use malted grain. Over the years, we've used enzyme at times. We are not distillers. We're not distillers. We were not brewers or winemakers. We were rock climbers. So we had to figure this out as we went. And a lot of the time, we screwed up. We would just figure out a new way. And we're still trying to tweak our processes. I think every time I taste our whiskey, I think it gets better. And it's because we're getting better at what we're doing. So anyway, I set off on a tangent. Hey, how about we drink some whiskey? Sorry about that, guys.
Hey!
Yo, waiting for you. Oh, you guys have been so patient. Thank you. I don't have corn in my hand, but I've got 4 grain. But I would start with the corn. So let's start with the clear spirit there on your left. And that's the baby bourbon just before the barrel. So those two, the one on the left and the one right next to it, it's the exact same spirit off the still. One is aged and one is unaged. So the corn whiskey comes off the still at about 75 to 78% alcohol content. And then we put it in a stainless steel, cut it down with water, and we bottle it. This is what we would call a new make, or a white dog, or a white lightning, not moonshine. Why?
Illegal.
That's right. We paid all our taxes, that's why. And that is, this corn that we use is unique. We'll go back to talk a little bit about the grain. The corn is a blend of the field corn and the heirloom varietal corn. And these are both grown on a farm about 3 miles from our distillery. And that blend gives us the flavor profiles we want from those heirloom corn, heirloom grains, and the oil content that we want. And then we get the starch content and the yield, just general yield on the farm of grain on the field corn. And starch means more starch means more sugar, means more alcohol.
What proof are you distilling to?
I'm sorry?
What proof are you distilling to?
We distill up to just between 75 to 78 typically. Sometimes as high as 79, but somewhere between 75 and 80. Can't go above 80.
Well,
No, we can. We just couldn't call it.
that's part.
That's it. Yes.
What percentage of heirloom corn are you using?
Now we're probably using about 40% heirloom corn. At one point it was about 60%. Now it's about 40%. That's really low yield. I mean, when we bring that to our farmer to grow for us, these are like old school Hudson Valley, salt of the earth farmers, and you try and get them to grow this Wapsie Valley seed that is going to give him 1/10 the yield on 1 acre as his regular field corn, and he has no understanding of what you're trying to ask him to do. Why would I do that? And then you don't want me to spray it? What? But if I don't spray it, then we're going to lose even more. So we don't get a lot of it, but it's worthwhile for the flavors that we're getting on there. Yeah.
Do you need 40% of your total mash bill or 40% of the amount of corn?
Of the corn.
Okay.
Of the corn. All right, so get back to the mash and the starch conversion. So now we've ground the grain into the water. We're now going to bring the temperature up. So we bring the temperature up to about 170 for us, and we cook it, and that's trying to marry the water and the grain together to really make a mash and access those sugars. And that heat is going to help to start to break down the starches into dextrins. And then as it cools down, we'll add malted barley to it. We can't add malted barley too high because the amylase enzyme will actually die off before it starts its process. So as it's cooling, we'll add that malted barley, and we're going to check the Brix level. Brix is basically sugar content or suspended solids in solution, which basically gives you the percentage of sugar content. There's a more complicated equation for it, but for ease of this discussion, say 18 Brix would be about 18% sugar content. So our goal is to get as high Brix as possible, because the most sugar we can get, most of that starch we can convert into sugar, the better. That means more alcohol we're getting on the other end. And then we want to bring that sugar content down. So basically, as you're watching fermentation, we're going to start with the Brix level up here, and as that sugar content goes down, what's happening? The alcohol content is going up. And by knowing where we started and where we end, we get a rough idea of how alcoholic the mash is as it goes into solution. And this process where we're converting the starch into sugar is called saccharification. Saccharine sugar. And we're looking at basically the types of sugar that we're going to get from this process is glucose, which is dextrose, same exact thing, glucose and dextrose. But these now are simple carbohydrates and easily converted into alcohol by the yeast. So the yeast can digest them. This just gives you a visual on what that process looks like. So we've got the starch molecule, which is a complex carbohydrate, and we've got to break down these bonds so that we can get the individual sugars. And there are two types of amylase, these enzymes that we're using that occur naturally through malted barley, or that you can buy. There's a beta and an alpha enzyme, alpha and a beta amylase enzyme, and both are doing different things. The beta is basically, beta comes in and chops this kind of in half, chops it like that, and then the alpha enzyme can come in and it can break down the bonds in between the individual carbohydrates. And then once you've got those bonds broken down, we've got those single sugar cells or molecules. At that point, we can introduce the yeast. Any questions on this? Okay. Like I said, it's basically just pooping out our alcohol. So now we've got that accessible. We're going to add the yeast. For us, we start with dry yeast. We're going to activate the yeast with water. We actually introduce the mash to the yeast before we add the yeast back into the mash. So we'll start with a tub of yeast, we add a scoop of mash to it, and about 15 minutes after that, the solution starts to bubble up, and at that point we know that the yeast is active. If we were just to throw the yeast straight into the mash, probably get overwhelmed and it doesn't really activate. You add a little bit at a time and it starts to catalyzes that conversion. Activates it and introduces the yeast to the sugar it's going to be converting. It's just an easy way of activating it. And then we inject it into the mash as it makes its way over into the fermenters. We use 2 different types of yeast for our process. And we do that because you're getting different flavor profiles out of different strains of yeast. And also they work at different sort of points on the spectrum. So as you know, one strain is active in converting sugar into alcohol and starts to die off. The second one picks up where the first left off and will give us more conversion, and we're going to end up with a higher alcohol content on the end. And convert more of that sugar into alcohol. We want to convert as much of that sugar into alcohol as possible. We don't want to leave a lot of that sugar behind. And the other byproduct of fermentation is CO2. Yeah?
Just curious, is there some sort of like yeast catalog where you can go through and be like, oh, this yeast adds this, this yeast adds this, or is it just kind of a...
You mean as far as flavor profiles and things like that? I'm sure there is, but also yeast, and there's just billions and billions of strains of yeast out there. So there are certain strains of yeast that have been propagated at labs that you can purchase, and those, yes, you can look through the catalog and they can tell you, where they come from, what kind of flavor profiles you're going to get from. But also, there's, you're breathing in yeast right now, so you want to. We leave an open top fermentation process because we want to allow the ambient yeast from the environment into the mash, and that gives it, it's very subtle, but it will give a certain terroir to our area because the yeast in every individual area is going to be different based on the plant life around here. Yeah.
Is the second yeast, is that a economy situation, or is that like to make it more affordable, or is that, because like you said, it picks up where the other one leaves off? Is that part of that?
Yeah, it's
Obviously,
2 things.
You get different flavors, obviously. But
Both of those things. We get different flavors out of each strain. We want those different flavors, and the other side of it is that we get more alcohol. If the first one starts to die off, there's still a lot of sugar left over. And we use a brewer's yeast and a distiller's yeast. So brewer's yeast will actually, you're going to ferment a lot longer with the brewer's yeast. So when the distiller's yeast starts to die off, the brewer's yeast picks up where the distiller's left off. That's pretty cool. And these are some photos I found of actual yeast cells. And they self-multiply, so my dad always says it's like the best workforce. You only have to pay them once, and when they're done working, they just die. And there's millions of them. Yes, Tim?
How long of a fermentation period do you have? Do you play around with it much, or?
Yeah, well, for us, we're at about 5 or 6 days. But you can do a lot quicker fermentation, sometimes 3 days, and you can slow it down, and you can drag that fermentation process longer. When you do a long fermentation process, you have to be very careful of sterilization. The shorter fermentation process doesn't allow toxic compounds to grow. The yeast are actually, they're not only this great workforce, but they're also like a little army, and they will combat anything that's growing in there, any bad bacteria that's growing in the mash, but only so long. When the yeast start to die off, then you're going to have the ability to grow these nasty bacteria in there. So we try and keep it a short period of time so that we don't have the opportunity to grow these nasty bacteria. But you can ferment for a lot longer, and you can do natural fermentation where we don't even add yeast, and you can ferment it for a lot longer. But you want to make sure that you have closed vessels when you're doing that. Yeah.
Do you guys do you keep like a culture of the yeast and keep it like on site, or is it something that you bring in?
Some we bring in, and we've played around with trying to propagate our own yeast, and at some point we'd like to do that, but we haven't gotten to that point yet. But yeah, there are a lot of distilleries that just keep their mother yeast and they just scoop from that and just keep it going. But we don't do that at this stage. We buy dry yeast and we activate it. I get it from a lab out in California. So I'm not really doing a tasting, as you can tell here. You just feel free to drink these as we go. We're talking more about distillation than about Hudson whiskey today, but you just want to have something to drink. So if we can go to the next one, the Baby Bourbon. Baby Bourbon is our flagship. It was the first bourbon ever produced in New York State. The first legally produced whiskey in New York State since Prohibition. And it's a majority corn. It used to be all corn, but we've scaled back. We add a little bit of malted barley to it now. And this is it's what we sell the most of. It's a nice, easy drinking whiskey, and that's a blend of our two corns.
Where's Baby coming from?
So it's really a fanciful name. We're in baby bottles. When we first started, we had a 100-gallon pot still for the first 2 years of production, which meant that our cook tank was 400 gallons, which meant that we had to run it 4 times, which typically would take us 4 days. Because we weren't working around the clock, and then we would have to rectify it on the 5th day. So by the end of the week, we had maybe one 53-gallon barrel full of whiskey. So if we go into smaller barrels, though, that allowed us to see if we were even going in the right direction. So we were using these baby barrels because we didn't have a lot of product. We wanted to see how fast it was going. When I say baby, slightly larger than these. 3-gallon barrels is where we started. We don't use this 3 gallons anymore. We use 5 gallons sometimes, but mostly 10-gallon and up. So basically, we have these baby barrels. We have these baby bottles. We were making so little. We were using extremely expensive grains. We were using extremely expensive barrels. A 53-gallon barrel to mature whiskey is about $3 to $5 a gallon, something like that, maybe even less. Whereas a 3-gallon barrel was costing us about $40 per gallon to mature. So we're doing everything really expensively. So if we have only 50 gallons of finished product a week, and it's extremely expensive to make, well, if we put it in smaller bottles, we're going to spread ourselves out a lot thinner. We're going to have a bigger footprint. We're also going to be able to, I hate the term liquid to lips, but you're going to get people to try something that they haven't tried before. If you got an $80 bottle of whiskey from New York that nobody's ever heard of, it's kind of hard to buy that. If you got a $40 bottle, it's still expensive, but at least I can try that and see if I like it. Yeah.
Have you considered the tagline, "Nobody puts baby in a corner"?
I like that one. That's good. There's so many opportunities with baby bourbon. No babies were harmed in the making of baby bourbon. Yeah.
Quick finish. Do you have any TCA problems?
I'm sorry?
Do you have any TCA problems with your cork finish?
We don't on the barrels, you mean?
No, in the corks that are in the bottles.
Oh, so every once in a while we do, yeah. We've gotten cork bottles back, and every once in a while.
There's a slight, and not in the nose, but in the mouth with the white dog.
With the white dog.
Yeah, just a slight.
Oh, that might be. It might be. Okay, well, thank you for letting me know. If anybody tastes that and they want to try some more, we've got some more up here afterwards. He was asking if we ever get cork problems, because we do. Actually, no, the corn whiskey is a synthetic cork, so we probably do. But we have gotten cork bottles before. All right. Any questions? Any questions? All right, good. Moving on. So I have to get to distillation at some point too, right? This I have no idea. Anybody else want to explain this to me? And there's really still not a whole lot known about what's actually happening during fermentation. And this is kind of what's happening, but why and how is still kind of elusive. But basically, you're taking the sugar, and then you got these swirly things and stars, and then out comes out ethanol and CO2. Yeah. Good. All right, you got that? So the main products of alcohol fermentation or grain fermentation, you get the different types of alcohols you get. You get methanol, ethanol, which is what we drink mostly, ethanol, propanol, butanol, methylbutanol, fusel alcohols like acetone and aldehydes. We also have congeners, which are substances other than alcohol that are what gives your whiskey a lot of the mouthfeel and the flavor profiles that we associate with whiskey. Tannins, esters, things like that. And then we also have carbon dioxide. And carbon dioxide, for us during our fermentation, we get a lot of CO2 coming off, and part of the way we know that our fermentation is done is because the CO2 is coming up and it's pushing. We do a whole mash fermentation, so we don't lauter, we don't separate solids from liquids. We allow this whole mash to ferment and distill together. So what's happening is the CO2 pushes the grain up to the top, and you get this big cake on top. And then towards the end, as the CO2 stops, it starts to sink and drops down. And at that point, we know we're getting towards the end of the fermentation process. It's me and my dad looking at the fermenting, and you can see it really bubbling away. We don't use these fermenters anymore. Actually, we do, but for small batches. All right, so just a quick distillation slide. Also, Alex arranged to actually have a still in here. We wanted to have it running, but that probably was not legal. But you guys can feel free to come up and take a look at this, and as we talk through about different types of distillation, I'll talk a little bit more about this. But the basic idea, right, is we start with the fermented mash or wort or wine or whatever that's fermented. It's got alcohol in it. We heat it up. The alcohol vapor starts to evaporate up. This type of still is basically a fraction column. So we're going to look at different types of stills. Now, the definition of distillation: process of separating component substances from liquid. From a liquid mixture by selective evaporation condensation. So liquid mixture can be any sort of fermented liquid mixture. Component substances, what are the component substances? Well, we had talked about different types of alcohols. Those are the different component substances. Separation, how are we doing that separation? A lot of that has to do with temperature, how we're separating the different components. And then condensation, so that vapor comes off and then it gets collected, goes through a coil or a worm or whatever you want to call it. It comes off and goes into a condenser where it chills that vapor back to a liquid and we collect it. Very basic. I think we all understand that aspect of it. Now we've got different types of distillation for whiskey. We've got basic distillation or pot distillation, which is picture. We'll get back to that. Pot distillation, if you think about a distillery you might see in Scotland, or Forsyth stills, or if you've been to Woodford Reserve, you got these big pot stills. They come up and they sort of gooseneck over, or swan's neck, whatever you call it, and it goes directly into the condenser. Now this is a great still for making whiskey. If you want to make just whiskey, these are fantastic. If you want to try and make other things, and you want to get higher proofs, this might not be the ideal still for you. We work with the second type of fractional distillation because we want to be able to make a variety of different things. So on the basic pot distillation, you just have a pot, a heat source, the alcohol comes off, it goes in the condenser, condenses it back to the liquid, and we collect it. Fraction column, which is what this is over here, is a way that we can separate out the different components. And this is where we end up getting really sort of scientific about it, and this is where you get I think much higher quality because you can separate out the components we do want from what we don't want in a much easier way. So hybrid still, that's kind of what we use. We've got a pot and we've got a column. So these are still batch stills, like the basic still, but instead of going straight from the pot into the condenser, we go through a column like this, where it goes up through bubble plates. You can actually pass this around if you want. You can see these are the plates that are in there. Each one of those holes has one of these little bubble tops or bubble caps in here. And basically, as the alcohol vapor comes through, it's going to condense on each different plate. Each different plate is going to be a different temperature. If you think about a pot still, we use our pot stills, we've got a steam jacket around that pot still. So you put the fermented mash in there, the heat source is on the bottom of the pot. So as the vapor goes up through the helmet and then hits the column, each plate on that column is going to be a different temperature. So when it hits that first plate on the column, it's going to be cooler than the pot was. So it's going to condense, and it'll sit there until that heats up. And then it's going to bubble up again to the next plate as it evaporates. And that's going to be a different temperature. And it's going to condense. And it's basically redistilling its way all the way up the column. And everything that collects on different plates, you're going to have different components on each plate because they're going to be different temperatures, and different alcohols have different boiling points. Different boiling points here. We're going to come back to that, but just so you get an idea of the different boiling points. Methanol, which is what we would consider heads, comes off at a very low temperature where we're going to start to see ethanol at around 78%, 79 centigrade. Then we have the continuous distillation method, or the coffee still, which is there's no pot. It's just always it runs continuously, and this is where the fermented mash or wort comes in on the top or the middle of a column, and it falls down over these plates. So if you think about this still over here, without the pot, you've got the mash that would come in at the top, and it would fall down over these hot plates. And as it falls down, the alcohol vapor comes off the top, goes into the condenser. Reflux comes off the side. Reflux is the condensed alcohol or other components that are falling back into the still. Those will come off the side on a continuously operating still. And by the time the mash gets to the bottom of the still, the alcohol's been taken out, the vapor's been collected, and it's just constantly running. Now, if you think about a pot still with a whole mash, where you've got your grains and your solids and your liquids in there together, in a pot still, you're going to pull a lot more flavor out of that grain than you would if you, by the time the alcohol was taken out of the mash, it was gone. So as soon as the alcohol is taken out of the mash and continuously operating still, it's gone. And you don't get any more of those flavor congeners or oils that are coming through. So you feel like you get a lot more flavor and also a unique mouthfeel off the pot still than you would on a column still. And column stills are typically used for vodka, sometimes for whiskeys, and also for spirit whiskey, like if blended scotches, Irish whiskeys, when you're distilling up to a higher proof, as opposed to American whiskey, where you're coming up like 80% or below. Okay, any questions on the different types of stills? I'll try to work my way through this. We haven't even gotten any. All right, move on to the next whiskey, guys. All right, we're on the 4 grain. All right, so the next one is the 4 grain. That's one of my favorites. The baby bourbon's all corn. We do an all rye whiskey. We do a single malt, which is a malted barley. The 4 grain is corn, wheat, rye, and barley. It is a bourbon, so it's about 60% corn, and then a fairly even blend of the other grains. All right, so where are we here? So how come it tastes so good? And I can still see how come I haven't gone blind off this. How do we do this? We do for us, we do 2 different distillations. We do a stripping run and a rectification run. Stripping run is where we're going to take out all the alcohol out of the mash. So we put the pod, fill up the pot with our fermented mash, we boil off all the alcohol, pretty much take it down almost to 0. And at this point, we've got what we call low wines. We discard the waste, the mash goes out into a tank, a couple tanks, separate out the solids from the liquids. The solids go to a local cattle farmer. The liquids go up into a reed bed system that we built, a wetland basically. What was they talking about that for? Sorry.
Why is it so good?
Why is it so good? Okay, right. Stripping run, thank you. I had a late evening last night. I'm still sweating it out now. So we take the low wines, we put them back into the still, and we're going to run them through again. And at this point, this is how we're going to separate out what we do want versus what we don't want. And we do these based on temperature of the distillation process. So the 3 parts of the distillation for us, for a distiller, making whiskey, where you're going to cut is your heads, your hearts, and your tails. Our heads are going to be mostly methanol, and that's because you saw it comes off at the lowest temperature. Conveniently for us, the things we don't want to drink, for the most part, come off at the lowest temperature. They're much more volatile than ethanol is, which means that we know that the first things coming off for 4 shots, the heads, are going to be this nasty stuff that we don't want. We'll collect it, we measure it, we know about how much of each batch is going to be heads, so when we get to a certain volume, we're going to say, okay, we're probably going to start coming into hearts now. And at that point, this is really where the craft of the distiller comes in, is understanding how to make that cut and what the flavor tastes, the difference between enough, too much heads into our heart cut, not enough heads into our heart cut, and making sure that we've got a good clean cut so we get all that nasty stuff out of there. The distiller, at our distillery, will actually sit there and smell it, taste it. Now it's still too sharp, now we still got some of that methanol in there. All right, it's good, collect it. We cut off the heads, start collecting the hearts. If you look at a distillation run on a chart, it looks like a bell curve. And as the still gets hotter, you're going to work your way through the bell curve. And as the still gets hotter and you work your way through the bell curve, the alcohol content drops. So it's basically like this big X over the bell curve. And then center of the bell curve, the hearts, the ethanol is what we want. When the still gets too hot and the alcohol contents drop to a certain point, at that point we're going to start distilling a lot of the tail. We're going to start getting propanol, methylbutanol, distilled water, and fusel alcohols. At that point, we're going to cut it off. We want some of these things in there for flavor and for mouthfeel, but too much is going to give us a subpar quality, a subpar final product. So we'll cut off the tails. We collect the tails. Once we might end up with, off of one batch, 25 gallons or so at about 80 proof. So that's a lot of good alcohol. So we'll take that and we put it back into the next batch of low wines and redistill it. Once we've taken the heads off, we don't want to reintroduce the methanol. Some distilleries do. Once we've taken that methanol out, we dispose of it. Yeah?
So you kind of gauge that by tasting the heads and tails?
Yeah, well, for tails, we cut it at a certain temperature and a certain proof. So when we get to 60% alcohol content, like I said, the alcohol content is dropping as the distillation run goes through on a pot distillation, because you're running, just running out of alcohol. And when it gets down to a certain point, at 60% alcohol content, we stop collecting the hearts, we start collecting the tails. We take those hearts, we cut it down with water, and it goes into barrels. Good? Did I answer your question?
Is that dangerous to taste the methanol?
I mean, you're really just, you put it on the back of a spoon, you're smelling it, you know, you may taste a little bit, but it's really, we know we've made it through most of it by the time somebody's tasting it and smelling it, because we're doing it by live. Got to cut off? Oh man. Wow, well I didn't get through nearly any of the slides here, so if anybody else has any questions, I can maybe send you guys this, but I'm just going to flip through these real quick. Just want to see different types of stills. Typical Scotch stills, column starter coffee still. You got it's actually one of our stills on the left. That's a hybrid still. So you got the pot, the column, and the condenser there. Barrel maturation. This is where it got really geeky. So I go on this for another like 2 hours on barrel maturation. But the main three tenets and why we mature wood, and not necessarily why we started, but why we do now, is because we get reaction, evaporation, and interaction. So the reaction is actually where you're going to break down components of the wood from a non-soluble to soluble. So that when we put the spirit in there, these flavors come out of the wood and into the spirit. So we've got like aldehydes, which are naturally phenolic compounds in the wood that will go from aldehydes to acids to esters. And esters is the final product. When we get there, that's what we want. That's where we get really unique whiskey flavor profiles. And 60 to 70% of the flavor, everybody knows is whiskey, is coming from the barrel. So this is a really important step in the process. But I think I made it through at least the distillation process. Did anybody have any questions about distillation? No? Fermentation? All right, good. If anybody wants this, I can send it to them. Give me a card and I'll send you guys this deck. But it gets really geeky here, so for anybody who really wants to get geeky, we talk about acids, aldehydes, woods. It tells you the different types of aldehydes, esters that are giving you different flavors, like fig tobacco, talking about woody, and all these different flavor profiles. This is where they're coming from. Ethyl syringate, you get tobacco or fig in a whiskey. That's coming from this component of the wood that's dissolved into this spirit. You got ferulic acid, which clove and spice and cinnamon, esters, vanillins, where you get your vanillins from. This is what these look like and how we get to those flavor profiles in our whiskey. Evaporation, I told you about that. Different sulfides will evaporate out to the wood. Over time, we're going to get mellower spirit. Filtering and packaging, we just do paper filter or cotton micron filter. We don't do charcoal or chill filtering. Both are really efficient ways of taking out a lot of impurities, but sometimes impurities, at least for our whiskey, we like the impurities. Gives you mouthfeel and gives you cool flavor. Drink some rye. Thank you guys so much. If you have any questions, feel free to ask. I'll see you guys around. And I think